Hi, welcome to the Mule Soft Architect course. In this video, we'll understand about the NIO concept, or we call as non-blocking IO. So this is used by the HTTP component in Mule 4. So this is bit tricky concept. So if you're not getting this in one, so you can watch this video again and again until you understand about the concept of NIO. So we'll start with the system. So before the NIO, so we'll consider one scenario where we don't have NIO and we have the normal HTTP server. So let's take an example. This is my HTTP server. So HTTP server, so there will be one main thread which will be listening to one of the port. Let's say the port is 8080 and we'll configure the server socket on this port. So we have server socket. So let's take one scenario. So in this scenario, we have one client and this client is want to interact with this HTTP server. So so here we are listening to HTTP server with the server socket. So whenever client is trying to connect with HTTP server, this will use one port, that is 8080. So we have opened this port 8080 for the connection. So after connection with this object, what this main thread will do is this will create one more small thread and one socket object. So this is nothing but one socket object. So this socket object will connect with the client and communicate the data. So this is nothing but whenever you want to connect with the HTTP server, you will use the server socket, and for the communication, you will use the socket object. So let's say there are n number of client, C1, C2, n number of client. So you will have the n number of socket object and n number of threads. So the main difference between the socket object and the server socket is used for the connection and the socket object is used for the communication. Now we'll see how this client internally communicate with this socket. So any connection from the client to the socket is nothing but one network call. So this network call is used to communicate from the client to the socket. So socket cannot directly communicate with this. So for that we need one device driver which is used to communicate with the client. So we'll have one device driver. So this is software and we'll have one network adapter, or you can say the network card. So inside this network card there will be one software, that is the device controller. So whenever this client want to communicate with the socket, what this will do is socket will communicate with the device driver and tells her that I want to communicate with this HTTP server. Device driver will sends the data to the device controller, and device controller will activate this network card, and so this network card basically knows how to communicate with the client or the network communication, and this network card will sends data to the client. And yeah, in this way basically this internal structure of any server communication works. So now I will summarize this HTTP server. So we have HTTP server. Now we have opened one port 8080 which will use to communicate with the client. So this is my server socket. So once a client want to communicate with this HTTP server, client will call to the server socket. Server socket will create one socket object, and this will attach one thread to the socket object, and all the communication now onwards will be done with this socket object, not this server socket. And if we have n number of client, we'll have n number of server sockets. Sorry, socket object, and n number of thread also. Come like this. And any call with the socket object to the client is nothing but a network call. So in order to achieve this network call, the socket object will call to the device driver. Device driver will communicate with the device controller. Device controller will tell the network card that I want to communicate with this. So network card knows how to do communication with the third part or the network. So this network card will send data to the client. So this is the scenario of the HTTP server if this HTTP server is not using non-blocking IO. Let's take one more scenario in which this client is sending data to the socket object in a slow speed, or there can be a network glitch, or the network speed is slow. So what will happen? Let's say this client 1C1 is sending data to this object, socket object in a slow speed. So this thread will be idle for some amount of time. In a similar way, if I have 100 clients, then I have 100 idle threads. So what we are so there is a problem over here because all the threads are blocked until the network speed is faster. So this is nothing but one blocked IO. Now we'll see one more scenario with the non-blocking IO. Before starting the NIO, we'll go through few concept of non-blocking IO. So anything we want to read in NIO, we'll read from the channel. So we'll have like this kind of channel, and all the reading operation will be done by this channel, and we call this as socket channel. To read the data from the socket channel, we'll have one thread which will read the data from the socket channel. And whatever we'll read from the socket channel, we will store that into one buffer memory. So how this socket will take the data from the network? So in the similar way in previous slide we saw. So this will have one device driver, and this device driver is connected with the network card, and we have one driver controller, or we call as DC or controller anything. So this driver controller will take the data, transfer it to the device driver will transfer data to the socket channel, and socket channel will store that data into the buffer. Through this whole process, in, until my until I receive the data from this network, my thread will be in idle state. So we can say that this thread is blocked until we receive the record. So one of the way to free this thread is we'll call this thread read socket channel dot read async. Asynchronous means this will run in background. To achieve this asynchronous, what we need is we need one selector object. Once we have this selector object, what we can do is we can register this channel to this selector object, and if we have more than one channels, then those channels will be registered to this selector object. And as we know, this main thread is listening to all the connections. So what this main thread will do is this will create the channel and register this channel with one of the selector object. So this main thread will be free to work, and this is not blocked. So there will be one more thread inside the selector object, so that we call a selector thread. And there is one method inside the selector thread, selector.select. What this thread will do is this will take the data from the channel and create one more thread and send the data to this thread. So let's take an example. I have three channels right now, and out of which these two channels we got the data. I mean, these two channels executed the data, and we are ready to publish. So what this selector dot select thread will do is this will give me the array of these two channels and assign two different threads, create two different threads, and assign these channels to these threads to for the process. So in this whole process, we are not blocked. So this thread is not blocked. This thread continue listen to different request, and once this channel is completed with the request, this selector thread will select the completed request and create one more thread, and rest of the execution can be done. So this is nothing but non-blocking IO, because these threads are not blocked. So all the threads are used very efficiently. Now we'll see how this NIO is implemented in Mule using the HTTP method, HTTP connector. So let's take an example. This is my HTTP, which is listening to one of the port, let's say 8080. And so for this, we have server socket channel. So we'll have this as a server socket channel, and we have clients which will call these HTTP request. After calling this HTTP request, let's say client 1 call this HTTP with 8080 port number. So what this server socket channel will do is this will create socket channels for each request like this. So let's say we have three clients who are calling these HTTP API. So we'll have three server sockets. And this will also create one selector object, and there will be one selector thread. So what the selector thread will do is this is continuously listening in an infinite loop whether our channels are ready with the data or not. So these channels are basically communicating with these clients directly for the communication. So once the data is ready, this will our selector thread, and there's a method called select as I told you. So selector.select thread method will give you all the thread which are ready with the data. So let's say these two channels are ready with the data. These two channels will be given as an output response in an array. And what this selector thread will do is this will execute, this is going to execute my process. So for that, there is a worker thread pool. This inside this thread pool, we have different available threads. So these threads basically will be used in order to execute this selector of this channel socket channels. So what this selector thread will do, this will assign the thread from the worker thread pool and execute the operation or get the data and send it back to the client. So there is one more concept in this. So in few implementation of HTTP, there's a possibility they will not use this worker thread pool. Instead of this worker thread pool, what they will use different selector threads. So let's say I have 1 2 3 4 5 this selector and this 6. So there will be 6 selector object, and once I get the request in channel socket and is ready to move the data, so what this will do, selector thread will assign these socket channels to any of the selector object, It depends on the algorithm, like which selector object will be selected, but this will be take care of by this selector object, and all the requests we are getting will select one of the selector object, and this selector object will send data to this thread. Instead of this sending data to the worker thread pool, this thread only executed it and send the result back to the system. So in this way, there can be two implementation, one with the worker thread and another with the selector thread only. Instead of sending to the worker thread, the selector thread only executed the program. Now we'll check from the MuleSoft side also internally how it is work. So let's come to the MuleSoft. In Mule, we are using HTTP component. And internally it is using Grizzly. And Grizzly framework is implemented in NIO. And Grizzly maintains the selector thread pools. So for our HTTP listener, we'll have one main thread which will listen to one given port, let's say 8080. So this main thread will internally delegates to the Grizzly. So every HTTP listener uses a separate thread pool. And in last videos we saw we'll have three thread pools: CPU light, CPU intensive, and the blocking IO. But for HTTP, for listening HTTP, basically we'll one more thread pool that we call a Grizzly thread pool. And this Grizzly is basically using NIO, that is non-blocking IO. So let's take an example. Suppose you are running one few applications on Mule runtime. This A, this is B, this is C. Application A has 3 HTTP listener flows. This is having 2 HTTP listener, 1 HTTP listener. So there are total 6 HTTP listeners, all are inbound connectors. So how many Grizzly thread pools are required for this? For all the applications. So it is only one unit required, a Grizzly thread pool. So in one runtime, there will be one shared Grizzly thread pool. So all the HTTP listeners in all the application sharing a single runtime will have the one Grizzly thread pool, which will be shared by all. So if you are using a HTTP requester that is in outbound, so every HTTP requester has its own dedicated Grizzly pool. So we basically need non-blocking IO for requesters also. So we have dedicated Grizzly thread pool for requesters. So let's take an example now. So this is my Mule runtime, and this is my application A. This is my application B. I'm configuring 3 flows, let's say A, B, and C. So here I'm using one HTTP requester. Here also I'm using HTTP requester. Here also I'm using HTTP requester. Let's say this two HTTP requester calling to one of the RESTful API, REST one, and this is making to the other REST API, that is REST 2. So how many dedicated Grizzly pools are required? So basically we'll require only one dedicated Grizzly pool. grizzly per application. So So these dedicated grizzly pools are per application if we are using for request, and if the same we have for the listener, we'll have one grizzly pool for the whole one runtime. And wherever we are, our application is calling IO call, whether it is a strip listen, requester, listener, or file input output, this will be used by the NIO concept. It is non-blocking IO because we don't want to block the threads. Hope you understand the non-blocking IO. In next video, we'll go through the how understand about the different types of thread pools used by the Mule. So that's it for this video. Thank you.